Hey everybody, so let's go ahead and get started with our Unit 6 review, and this is all in preparation for our Unit 6 exam that is coming up over logarithms and exponential functions. Let's go ahead and get started. So this first problem is saying identify the type of function and common ratio for the table of points below. So what's going to be given, and I have my own work here, but we're going to be given a table here. And how I solved this is I went into Desmos and I used the regression formula because I saw that these aren't moving in nice easy steps. So this has to be some type of exponential function. And I used the equation y1 tilde of a, b, x, 1. When I put these points in, I get this graph here that you see here in blue. Okay. And this is a pretty good representation as r squared is equal to 1. So this is a solid line here. And then in doing this, we get that a equals 0.333. We'll leave it as that. And b equals 4.000. Okay, so with these, we can then come up with our equation. Y equals, and we'll put this in parentheses, 0.333 times 4 to the power of x. Okay, now the question is asking, well, what type of function is this? Well, this is obviously going to be exponential. Okay, and the next part is asking us for the common ratio. Your common ratio is always going to be your base value. So my base value in this case is 4, so we would say exponential with a common ratio of 4. Okay, if you have any questions on how to put this into Desmos, please send me a message on Teams. I'll be more than willing to help you out. All right, guys, let's go ahead and move on to your problem. You're going to be doing the exact same thing, except you're not going to get the graph. You need to come up with your own graph. Remember, for your graph, you're going to use y1 and the tilde, okay, a, b to the power of x1. So we already know, hint, hint, this is going to be exponential, but I want you guys to solve for the common ratio. That's the important part. Now be careful, is common ratio A or B? It should always be your base value. All right, let's go ahead and do that one, guys, and I am taking this for credit. Let's go ahead and move on. So this question is saying to identify the parent function and state the transformations for the function below. So we have an exponential function, so my PF here, my parent function, okay, is going to be f of x equals my base value, e to the x. And everything else that's here, this 1/2, this plus 1, and this minus 2, these are all going to be transformations. Well, this is my a, my h, and my k. So I have an a equals a 1/2, so that's going to be 1/2. And because it's a 1/2, it's going to be a vertical compression. Had it been a value greater than 1, well, then we would have had vertical stretches. Okay. My h here is this x plus 1. And so it's really meaning that x equals -1, which is going to be 1 unit left. And my last value, my k here, is a -2, so that's going to be 2 units down. Okay. If you have any questions, please send me a message on Teams, and let's move on to your problem. So you all have the exact same type of question here. I want you to identify the parent function and then state the transformations. As a little hint here, you should have 1, 2, 3 transformations that are happening with this. Okay, go ahead and solve this problem, and then when you're done, move on. All right, so on this problem here, we want to expand the following problem. So we see this log of 8 times 11 times 5 to the third. This is going to be a rather large number if we had multiplied all these together, right? 5 to the third, 5 times 5 is 25, times 5 is 125, 125 times 11, and then times 8. Large number. What's nice about this question is it's already split up into factors, okay? So what we need to do and need to understand is we need to use the product rule, okay, where we had log of m times n is equal to log of m plus log of n. So that's what we're going to be doing here. We're going to split this up, but not into two parts, into three different parts. So we can say that this is going to be log of 8 plus log 11 plus log of 5 to the thirds. Now, you guys, I'm sure you've already noticed, like, hey, we have this power here, so we're going to use the power rule as well. And you'll recall that power rule is log of m to the n is equal to n log of m. So we can essentially bring this value down. And that leaves us, okay, with log 8 plus log 11 plus 3 log of 5. And we are done with this problem. Very cool, very cool. Again, we use the product rule to split each one of these factors into the addition of logs there. And then we use the power rule to bring down that exponent of 3 down to the coefficient. All right, if you have any questions, message me on Teams. And let's go ahead and move on to your problem here. And so this is your problem. Nothing really changes. Same aspects, you're going to have to use product rule. So hint, you're going to have to use product rule. And you will also have to use the power rule on this question here. Okay, well, let's go ahead and move on. All right, guys, so on this problem here, we've got y equals 5 log base 3 of x plus 1 minus 6, and it's saying, and that f of g of x is equal to g of f of x equals x, then what is g of x? So we can treat this as an f of x. And the reason this statement is important here is you'll recall if we have a composition of one function within the other and we get x, that means that we have inverses. So all this question is asking us to do is to solve for the inverse of what was given here. So if we have y equals 5 log 3 of x plus 1, okay, minus 6, and we want to solve for the inverse of this, you'll recall we need to switch our x and our y. When we do that, we're going to get x equals 5 log base 3 of y plus 1 minus 6. And now we need to isolate y. So what we're going to do next is we're going to add 6 to both sides, right? So we get x plus 6 equals 5 log base 3 of y plus 1. And this cancels out. Next, we divide both sides by 5. And let's write this up here. We're going to get x plus 6 over 5 equals, with these 5 simplified out, log base 3 of y plus 1. Now what I'm going to do to make this a little easier on us is I'm going to just switch these values, not mathematically, just because what we're going to do is we're going to do a little bit of a rule here. So we're going to get log base 3 y plus 1 equals x plus 6 over 5. And so what we're going to do here is we're going to write this in exponential form. And you'll recall, to write this in exponential form, we're going to take this value here and this one here, and we're going to switch them while dropping log. So we're going to get 3 to the power of x plus 6 over 5 equals y plus 1. Cool. So we actually only have one more step to go before we have y isolated. So the last thing we need to do is subtract 1 from both sides. And what we'll end up getting, okay, is we'll get y equals 3 with this crazy values up here, x plus 6 over 5, and all of that minus 1. And this is the inverse of our original function. It's a lot of work, but you guys can definitely do it. Okay, if you have any questions, again, please send me a message, speak up. You're going to have one of these to do on your own. So this is your question. I want you to solve for the inverse of this. Again, all of this up here just means you're solving for the inverse. So to kind of get us started, we'll say y equals 3 log base 4 of x minus 7 plus 10. To get that inverse, you're going to switch these values. So you're going to get x equals 3 log base 4 of y minus 7 plus 10. And you're going to want to solve for y. So you'll do your opposite operations. You'll subtract 10 from both sides. You'll divide by 3. And then to get rid of that logarithm, you have to write it in exponential form. Look at my previous problem if you had any questions. If you still don't understand, please contact me, guys. Don't hesitate to reach out to me. All right, so let's go ahead and move on to our next problem. So this problem here, it's asking us to solve for k. It's a multiple choice question here. The way I want you guys to approach questions like this, just because if we were to do this by hand, if we said 10 to the power of 6 k plus 2 equals 12. Okay, the way we could solve this is we could write this in logarithmic form where we take these values, switch them, but then we would have log base 10 of 12 equals 6k plus 2, and then we'd subtract 2 from both sides, so we would have log base 10 of 12 minus 2 equals 6k, but then we'd have to divide both sides by 6, and so we get k is equal to log base 10 of 12 over 6. So this works out, but you still need to solve for log base 10 of 12, and then whatever you get, you divide by 6, right? Well, use decimals for a problem like this. Let the calculator do some of the work for us. Again, I would like for us to practice by hand, but on questions like this, and for the sake of time, right? These are time tests, you want to work these out. So when you plug this into Desmos, please be sure that you always put the exponent in parentheses, like I have here, in parentheses, that exponent, and we get some value here. It's not an exact value, but it's pretty close to where it's like close to negative 0.155 and negative 0.15. So all of these here are obviously not anywhere near it, and so our answer here has to be A. Okay? So then on this problem here, I challenge you to solve this in terms of logarithms, but just also use Desmos to get your answer for this, right? So plug this in, make sure you put this exponent in parentheses, and then just zoom in as much as you can to identify that x-intercept. If you have any questions, let me know. All right, so this question says, write log 5 of a equals b in exponential form. So if we have log 5a equals b, when we're writing this in exponential form, you just take your a and your b, you flip them, and you drop log. So now we would have 5a, oops, not 5a, that is incorrect. We just switched it, right? We would have 5b equals a. So it's just a switching of a and b and dropping log. Okay? And so you're going to use that same skill on this question here. You're going to write log 9 of a equals b. We'll write this in exponential form. So switch the correct values and do what you need to do with the log. Let's go ahead and move on. All right, guys, so let's go ahead and look at this problem here. This is a transformation problem. It's giving us this graph, and it asks us to identify what happens to this point of 5, 1 after these transformations. So you'll recall when we have these logarithmic transformations, it's like this. It's y equals a log, okay, of h minus, I'm sorry, not h. It's going to be x minus h, and then all of that plus some k value. So what we need to do is we need to kind of take this one step at a time. So the first step is, you'll recall if we plug in a value here, what happens on the inside? So what's happening here on the inside is we're affecting this x value. So let's see what happens to x. Vertical compression, well that's A. No, we don't do that yet. Horizontal shift of 20 units. Horizontal means left to right. So yeah, so we're going to be moving right 20 units. So if I'm at 5 and I go right 20 units, I'm going to go 5 plus 20 is 25. So what happens here is my point is somewhere out here at 25, 1. Okay. Well, then you have to do a vertical compression of 1/2. So that means that up and down, we're going to cut this in half. So he's actually coming down half a unit. So now I would be at 25 and 1/2, right? Half of 1. So we've moved 20 units to the right. I took my half. And then my last step, because mathematically we did this part, we did this part. Now I have to do whatever my k is. Well, my k says shift up 1 unit. So that's going to affect my y. So I'm not affecting my x. I'm going to stay at 25. And I'm going to go up 1 unit. So then we'd be at 1.5. So 25 and 1.5. Again, we had to do this guy first. All right, we did this here. And then we did this step here second. And this is all in the steps of solving. And then our last part, 3. Okay, so the only one that affects the x value, okay, was that horizontal shift. It could be right or left. And then the vertical compression cut our y value in half because it was by a half, and our vertical shift of up 1 unit. Okay, so now you have this problem, pretty much the same concept, just a different point. Instead of the one we had before, now we've got 15, 1 as our point. We have a vertical compression of 1/2, a horizontal shift of 20, and a vertical shift of up 1 unit. Very similar, but you're going to get a different point. Try your best. If you have any questions and you would like to check your answer, send me a message on Teams, guys. Let's go ahead and move on. So for this problem here, they want us to solve this logarithm. Well, there were several ways we could have done this. We could definitely do this by hand. And doing this by hand, we could see that we could use the quotient rule. So we could take this log base 3 of x minus log base 3 of x minus 3 equals log base 3 of 4. So like I said, we could use quotient rule. Actually, we have to use that so we can drop these logarithms. So we want to combine these. And so using quotient rule, we're going to have log base 3 of x over x minus 3 equals log base 3 of 4. Now we can drop these logarithms because they are common logs, and we could say x over x minus 3 equals 4. To bring these x's up, we're going to multiply both sides by x minus 3. Okay. In other words, we could just multiply and kick this up here. And so we're going to have x equals 4 of x minus 3. We get x equals 4x minus 12. We can then subtract 4x from both sides. We get negative 3x equals negative 12. So let's write that again here. Negative 3x equals negative 12. Divide both sides by negative 3. we get x equals 4. That's a lot of work, okay? That's okay. You guys know how to use the quotient rule. You guys know how to solve for variables, but also realize that you can also put this into Desmos. And in Desmos, you can put the entire equation like I did here. Be careful, use your parentheses, and we see here that our line crosses there at 4. So I challenge you to do these questions like this on the review using algebraic methods, and then use Desmos to check. On the test, well, depending on time, if you want to do it by hand and you've got the time, do it by hand. If not, please use Desmos, okay? So then we have this question here. Guys, do this by hand. Follow the steps that I did in the last problem. If you are not able to do it, that is okay. But you can also check your answers on Desmos. This is a straight plug and chug type of question. Okay, again, if you have any questions, let me know. Let's go ahead and move on. And our last problem here. So this is the table to the left shows the closing prices for the NASDAQ stock index at the end of February during certain years. Using exponential model, write an equation for the curve of best fit, then estimate the year closing price will reach at $10,000. So when we put this in here, what I really want to make sure that you guys understand is we're going to do the same thing. We're going to use exponential regression. So we're going to say y1 and the tilde a b to the power of x1. This is the equation we're using. Now, when you plug this table in, okay, when you plug this table in here, look how I did this here. I didn't start at 1992. I have to start at 0. Anytime we use years, I'm going to say this again, anytime we use years, okay, you always want to start off at 0. And then we're going to see, how do I go from 1992 to 1994? Well, this was a plus 2. 94 to 96 plus 2. 96 to 98 plus 2. 98 to 2000 plus 2. So when I'm making my table, I go from 0 to 2, because that's plus 2. 2 plus 2 is 4. 4 plus 2 is 8. And 2 plus 4 is 6. And then 6 plus 2 is 8. So you want to follow these trends here. Okay, that's super important. All right. And then the y inputs stay the same. So again, years, you cannot put 1992. You cannot put any years at all. You have to start off at 0 and then count based off the changes in the table. And so what happens here is we see that we get A equals 242.63 and B equals 1.443. So that means that our equation would be y equals, and in parentheses, 242.63 times 1.443 to the power of x. And what's important is this has, it is pretty accurate. R squared is equal to 0.9616, which is accurate. Pretty accurate because it's close to 1. Okay, so this is nothing that you guys haven't done already. What's important to understand, though, again, is with the years, you don't put 1992, 1994, 1996, you put 0, 2, 4, 6. Okay, let's go ahead and look at your problem. So on this being your problem, is the exact same idea here, but when you're putting in your table, your x1 and your y1, well, your y values stay the same. So we're going to say 3.1, 4.6, 6.4, 9.5, and 14.2. Your x values are not going to be 1900. It's going to be 0. And then what are they counting by to go from 1900 to 1920? This was a plus 20. So we're going 20. Another 20 is a 40. Another 20 is another one. And we have another movement at 80. Okay, sorry, that looked 66 and it should have been a 60. So you have to look at that skip counting, and you're going to use the equation still of y1 tilde AB to the power of x1. So get your equation and state this is a pretty strong model. If you have any questions, please send me a message on Teams. If not, we'll see you later. Guys, thank you. I know this was a lengthy video, but this was to be done over 2 days. Have a good rest of the day. If you have any questions before the exam on Thursday, let me know, and we'll see you all later. Thank you, guys.